Hello, I need to talk about some concepts in modern control system, which is called controllability. It's a very important property in modern control systems, and the system is said to be completely state controllable if this condition here. So for any initial time t0, t0 here, each initial state x t0 can be transferred to any final state x tf. Tf, t final state, final time. In a finite time, tf is greater than t0, okay, of unconstrained control input. So if we have initial state at time t0 and we transfer this state from t0 to x tf using u of t and constrained u of t, so the system, we call this system is controllable because we have some authority on the states. We can move the state from one point to another. So we can call this system, if we have all the states, we have all authorities to all states, we can change all states from one time, from time step to another to some value. This state, we can change this state from some value to another value, so we can say this system is completely controllable. Okay, if we take an example for that, example for this thing. Okay, if you see this example, we have here a state diagram for this. We have this control input here, this control input, and we have y here. Okay, this is the output, this is the output here, and we have here this input, and we have for example, we can say this x1 dot, this x1, and we have this x2 and this x2 dot, and this x3 and this x3 dot. Okay, if you need to write these equations, the state equations here, okay, you can x1 dot equal to, it's minus a1 times x1 minus a1 times x1 plus u. It comes from here. Okay, this, we are talking about this one here. It's equal minus a1 times x1 plus u times 1, so plus u. Okay, and if you we need to write x2 here, this one, state variable, this one, so x2 dot equal to, it's just minus a2 times x2 minus a2 times x2 plus 1 times u here, so plus u. Okay, x3 dot equal to minus a3 x3 minus a3 x3 plus u. Okay, so we have only these three state variables. If you need to write it in a state form, in matrix form, I mean, minus a1 0 0 0 minus a2 0 0 0 minus a3. Okay, so we have this state equation here. If you need to write the output equation here, y will equal to, it's k1 times x1, k1 times x1, and k2 times x2, and k3 times a3. So we can write it k1 k2 k3 times the same state vector x1 x2 x3. So as you can see here, the control input here, it's 1 1 1 here, this control matrix here, control vector b, we call this A matrix, this B matrix, and this C matrix. Okay, so if you can see here, the B matrix all has 1, so the control input, has the effect to all these state variables. Okay, so this very clear clear indication that U has very great effect on this. There's many techniques you can verify to know if the system is controllable or not. We'll see it next in a few next lectures. And just need to point out now the concept of controllability, that if we have some control input and it will make the system to go from one state to another in finite time, and this control input is unconstrained. So this we call this controllability. Okay, just I need to point something here. If you can see here, it's diagonal. It's a diagonal matrix, and control inputs 1 on 1, and this in case of A has a diagonal elements, it's diagonal matrix, and B has all it's 1, so you directly from inspection you can say the system is controlled. Thank you for watching. See you next time.